Section 1.3, Writing and Evaluating Expressions. Here's the procedure to evaluate expressions. 1, I want you to copy the problem from the book as we have done on previous slides. 2, I want you to substitute the value given for the variable into the problem. And then 3, simplify using order of operations. Now, before we get into that, I want to take a look at multiplication notation. Here you can see I have 2 times 4, but here we're using parentheses. And we have 2 times 4, but using brackets, and 2 times 4 using braces. And essentially, it's all the same form, achieving 8 as our solution. More types of multiplication notations would be 3k. This is actually 3 times k. But since we're in algebra now, we want to use that there is nothing in between the 3 and the variable, and that would represent a multiplication. 3 times k, 4 times x, or 4x, 4 times a, or 4a plus 12, and here, this is actually x times y times z. And also, we state x, y, z. And here we have 3 times x times z. All notations for multiplication. Here our first example. I want to evaluate each expression. Number 1, 8 times y, or 8y. Here I want to use 7 for the value of y. So I have 8 times 7. And I use parentheses as my notation for multiplication. So 8 times 7 is 56. So I would copy this problem from the book. I don't need this part. And then I would substitute and then solve. Number 2, 3m minus 5, or 3 times m minus 5, where m is equal to 9. 3 times 9 minus 5. Here you can see I used a dot. I prefer to use a parenthesis, but I wanted to show you could go both ways. And a lot of times when you do this, you can make a mistake by putting 3.9. It's actually 3 times 9, which is 27 minus 5, order of operations. 27 minus 5 is 22. Continuing, I have 4 times x times z, where x is 2 and z is 5. So I have 4 times x, which is 2, times z, which is 5. 4 times 2 is 8, times 5. 8 times 5 is 40. Next, I have 23 minus 3a. 23 minus 3 times a. 23 minus 3a is 6. 23 minus 3 times 6 is 18, using order of operations. 23 minus 18, 5. Again, evaluating for a equal to 4, b 5, and c is equal to 12. Here I have a, b, c, or a times b times c. I have 4 times b, which is 5, times c, which is 12. And I have 4 times 5, which is 20, times 12. And this would be 20 times 12, which is 240. Again, I would copy the problem, substitute, and then simplify using order of operations. Here I have 8 times a. A is 4, divided by c, which is 12. That gives me 8 times 4 is 32 over 12. Now what I want to do is simplify. What is the largest number that goes into both of these? And that would be 4. 32 divided by 4 is 8. And 12 divided by 4 is 3. I can leave that as an improper fraction, but it has to be in lowest terms, which it is, 8/3. Here I have 4 times c minus a times b, 4c minus ab. I would copy the problem, and then substitute 4 times c, which is 12. Bring down the minus sign. A is 4, and b is 5. 4 times 12 is 48, minus 4 times 5, which is 20. 48 minus 20 is 28. Continuing, again, A is 4, B is 5, and C is 12. Here I have 2 times A, which is 4. And I have a set of parentheses here. So B is 5 plus A, which is 4. Order of operations, I can multiply on the outside, which is going to give me 8, but I also need to work on the inside of this, which would give me 9. Now, 8 times 9 is 72. I could have brought down the 2 and the 4 and the 9, and it still would have turned out to be 72, as that still follows the order of operations. Number 5, C minus A over B. C is 12, minus A, which is 4, B, which is 5. Now I have a 12 minus 4/5, so I have to have a common denominator. So this is essentially 12 over 1 minus 4/5. My common denominator is going to be 5, so I'm going to multiply the top and bottom by 5. 5 times 12 is going to give me 60 over 5 minus 4/5. And then I subtract, which is going to be 56 fifths. And that is in lowest terms. And number 6, A, which is 4, plus B, which is 5, minus 3, all over C, which is 12. And I simplify the numerator. 4 plus 5 is 9. 9 minus 3 is 6 over 12. And I simplify to 1/2. In this problem, we want to write an expression to determine how long it would take a person to drive to Pittsburgh. To do this, we need to answer a few questions. 1, how far is Pittsburgh away? 2, what is the speed or the rate that that person is going to drive? And then 3, we need to have a formula that relates distance, rate, and also how long, time. Well, we just happen to have that formula. Distance equals rate times time. And therefore, that gives us D equals RT. Variables that represent D, distance, R, rate, and T, time. Well, we know approximately that Pittsburgh's about 100 miles away. So we could put that in for D. And if we drive the speed limit, which is 65 miles per hour, and multiply that times T, we can determine how long it will take. In other words, I can solve this problem by dividing by 65 on both sides. So T equals 100 divided by 65. Now all we have to do is to plug that into a calculator and simplify that, and our value is going to be 1.538 hours, or approximately an hour and a half. Our next problem, we want to write an expression to determine the volume of a sphere. Well, first of all, we have to know what the formula for the volume of a sphere is. We can use a computer and use a search engine to figure that out. And it turns out the volume is V equals 4/3 pi r cubed. Now we have to know, well, what are these variables? V represents the volume, R represents the radius, and pi is short for a representation value of 3.14, approximately. Now what we wanted to do is figure out, well, what is our sphere given? What's it given us to be? Well, here it's given to be a sphere with a radius of 2. So now all I have to do is substitute in V equals 4/3 pi, R is 2, cubed. Now I can just plug that into a calculator, and I can get 33.51 units cubed, since this is a three-dimensional object. So the key to determining word problems like this is to figure out what they want, and also been able to use the variables, substitute values in, and then actually simplify the problem.